Okay, so this section should be very, very, very familiar because you talked about slopes of parallel lines and slopes of perpendicular lines in algebra last year. So taking a look at the two theorems, we're talking about if you have two non-vertical lines, they are parallel if and only if they have the same slope. And again, that's something you are already familiar with, but now you need to know that there is a theorem for that. So theorem 313 is about the slopes of parallel lines, and lines are parallel if and only if they have the same slope. So you would calculate the slope of each line. If the slopes are equal, then the lines are parallel. Going down to theorem 314, we talked about this yesterday in class, the slopes of perpendicular lines. So again, two non-vertical lines are going to be perpendicular if and only if the product of their slopes is -1. And that's what we talked about yesterday. We talked about doing like the opposite reciprocal. So again, this is now theorem 314, slopes of perpendicular lines. Lines are perpendicular if and only if the product of their slopes is -1. So calculate the slope of each line. If they multiply and give you a product of -1, then they're perpendicular. So taking a look at example 1, we're going to determine which lines are parallel and which lines are perpendicular. So here is your graph. So it says find the slope of each line. So starting with line A, you're going to pick 2 points on the line, and you can calculate slope using the slope formula. So remember, the slope formula you would have 2 points, x1, y1, x2, y2, and the slope formula is just y2 minus y1 over x2 minus x1. The other thing you could do to calculate slope if you're in the coordinate plane is you could use rise over run. I'm going to do it both methods so that you can see that you get the same answer no matter what. So I'm going to write these points down. So for line A, I have 2 points on the line. One point is -3, 2. The other point is 0, 3. And you can calculate the slope between those 2 points using the formula. So y2 minus y1 would be 3 minus 2. x2 minus x1 would be 0 minus -3, which is the same as 0 plus 3. So that gives you a slope of 1/3. So line A has a slope of 1/3. And if you look at the graph and you do your rise over run, you'll notice that you're rising 1 and running 3. So a rise of 1 and a run of 3 will also give you a slope of 1/3. So it doesn't matter which way you do it, you're going to get the same slope no matter what. Looking at line B, you're going to do the same thing. You're going to pick 2 points on line B and calculate the slope between those 2 points. So line B has points 0, -1, and 2, 0. So you can either do rise over run, or you could plug those into the slope formula. So y2 minus y1 is 0 minus negative 1, which is the same as 0 plus 1. x2 minus x1 is just 2 minus 0. So your slope for line B is a half. And again, if you use rise over run, you would rise 1, run 2. So you would also get a slope of 1/2. Line C, picking 2 points on line C, you would use -1, -5, and 1, -4. So y2 minus y1 would be -4 minus -5, which is the same as -4 plus 5. x2 minus x1 would be 1 minus -1, which is the same as 1 plus 1. So that simplifies to 1/2. And again, if you did rise over run, you would rise 1, run 2. And then the last line is line D. So picking 2 points on line D, here's 1 point on line D, which is -3, 2. And the other point on line D is -2, 0. So y2 minus y1 is 0 minus 2. x2 minus x1 is -2 minus -3, which I'm going to change to -2 plus 3. So that's -2 over 1, which is just -2. And again, if you did rise over run with line D, you would go down 2 over 1. And that simplifies to -2. So now we have to determine which lines are parallel and which lines are perpendicular. So remember, based off of Theorem 313, parallel lines have the same slope. So looking at my slopes, I could determine that line B is parallel to line C because they have the same slope of 1/2. So lines B and C are parallel. And if you wish to do so, you could use your symbols that you've learned. You could do B is parallel to C. Then for perpendicular, those slopes have to be opposite reciprocals, which also means that they multiply to -1. So there's actually 2 pairs of perpendicular lines because 1/2 and -2 are opposite reciprocals. So that means that D is perpendicular to B and D is perpendicular to C. So D and B are perpendicular, and you could put the perpendicular symbol down if you wish to do so. So again, -2 and 1/2 are opposite reciprocals. So that means D is perpendicular to B and D is perpendicular to C. So that's example 1. And so this whole page goes in your notebook as page number 35. Then page number 36, we're going to actually write equations of parallel and perpendicular lines using slope-intercept form. So example 2, write the equation of the line passing through point -1, 1. That is parallel to the line -y minus 3 equals -2x. So your first step is to find the slope of the parallel line. The line -y minus 3 equals -2x has a slope of blank. So before we figure, just assume, that the slope is -2, you have to put this into slope-intercept form. So remember, slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. So to put this into slope-intercept form, I would first add 3 to both sides. And to get rid of the negative, I have to divide every term by -1. So now, to put this original equation into slope-intercept form, I have y equals 2x minus 3. So now I could identify my slope as 2. So the line -y minus 3 equals -2x has a slope of 2. So by the slopes of parallel theorem, a line that's parallel to this is going to have the same slope. So it's also going to have a slope of 2. So m, your slope, is 2. So that's step 1, is to identify what the slope is going to be. Step 2 is to figure out what that y-intercept is. So again, we're trying to write an equation of a line passing through this point, -1, 1, that's parallel to this line. So parallel lines have the same slope. So now I have to find the y-intercept if my slope is 2 and my point is -1, 1. And again, we're putting this into slope-intercept form. So we're going to substitute 2 in for m, and then your xy is -1, 1. So x is -1 and y is 1. And you're going to solve this equation for b. So 2 times -1 is -2. Solve this equation for b. B is 3. So your answer, using a slope of 2 and a y-intercept of 3, is y equals 2x plus 3. That's the equation of the line that is parallel to -y minus 3 equals -2x and goes through the point -1, 1. So that's your final answer for example 2. Then example 3, you're going to do a perpendicular line. So now it says write an equation of the line passing through the point 2, 3, but this time it's going to be perpendicular to the line, and this equation is 2x plus y equals 2. So again, you're going to have to figure out the slope of this line. So the line 2x plus y equals 2 has a slope of blank. So first things first, put this into slope-intercept form. And you could do that by subtracting 2x from both sides. So y equals -2x plus 2. So my slope of the line 2x plus y equals 2 is -2. So I could put that right there in this blank. The line 2x plus y equals 2 has a slope of -2. So now we're going to get the slope of the line that's perpendicular to that. So you're going to have to get the opposite reciprocal of -2. So by the slopes of perpendicular lines theorem, a line perpendicular to this line has a slope of 1/2, because the opposite reciprocal of -2 is 1/2. So you're going to use a slope of 1/2. And remember, in the directions now, it has to go through the point 2, 3. So you're going to calculate the y-intercept if the slope is 1/2 and it goes through 2, 3. So you're going to substitute 1/2 in for m. X is 2, y is 3. And you're going to solve the equation for b. So 1/2 times 2 is 1. Solve this equation for b. B is 2. So the equation of this perpendicular line is y equals 1/2 x plus 2. And again, this should look very, very familiar because you did this last year in algebra. So what you want to do now is make sure that you glue this into your notebook, and keeping organized, you want to have the pages labeled. So again, the first page that we did was page 35. Make sure you put that into your notebook. And then this last example that we just did was from page 36.